Hi, this is Daniel. Welcome to Learning to Code in Scratch. So, Scratch is a very easy to learn, easy to use programming language developed at MIT, a famous university for technology and development. Scratch can be used to program all kinds of things. And today we're going to be looking at how you can make your own video game. When you first go to the Scratch website, it is at scratch.mit.edu. And you're going to see this page. You'll have to set up your own account, which will require your own email address. You can get some help from your parents for that. But when you look around at this first page, you'll see a whole bunch of projects that other people have done that you can open up and take a look at. But what we want to do today is to create our own project. So for that, up beside your account login, after you've made your account, you want to click on the folder which holds all of your projects you've done so far. You can see here several projects that I have already made for King Township Public Library, all of which you can find on our website if you go looking. We are going to start a new project by clicking this button right up here. And this is the workspace for a new coding project. There's several different parts you need to be aware of. The large square with the cat in the middle of it off to the right hand side is showing you what your program looks like so far. Beneath it, you have the details about the object that is selected in your program, the sprite. This one is called Sprite 1 and it is the cat. Underneath the details, you can see a little square with the cat in it showing you which sprite is currently selected. The large square space in the middle is where you will assemble your code in order to tell that cat what to do, or whatever other sprite it is that you're going to start programming with. Right now, we have the cat here. We are going to create our own sprite to go with him. So down at the bottom, there's a round button saying choose a sprite with different options where you can choose one of the sprites they have. You can paint your own sprite. You can get one randomly picked, or you can upload a small image that you already have on your computer to be a sprite. We're going to pick one from what they have here, and we are going to give our cat a little butterfly to play with. So, in the program window where you see what your program is like, you can click and drag your sprites around. Whichever one you select here, you will see selected in the box below. Or you can click on the squares below to change which one you are programming for. You will notice that in the big programming box in the middle, there's a little faint symbol up in the right top corner where it will show you which sprite it is that you are coding for. So before we get to any more programming though, there's one very important step to take. If you go over to the File button at the top on the left, you want to click there and click Save Now. And it says Project Saved up in the top right there. You want to save your project frequently, all the time. After almost everything you do, you want to click Save Project, because it really stinks to work for 2 hours on getting the code just right on some part of your program, and then the power goes out and you lose everything because you didn't save. So, save often. Now, we're going to write some code for our cat, Sprite 1. First of all, why don't we give him a little bit of a different name? We are going to name him Scratch. There we go. Little button comes up at the top, Save Now, making it easy for you to constantly, frequently save your program. Scratch programming works by building a set of instructions from little code blocks. You can see the blocks of code over on the left-hand side. There's different colors for different types of code. We want to start with events. Now you'll notice that there's slightly different shapes to these blocks. The ones that have this curve up at the top of it are the beginnings of a block of code. They go at the very top, and then the code gets stacked underneath like a tower of Lego bricks. So, the one that we have selected here, when green flag clicked, means that this block of code is going to start working when you press the green flag. The green flag and the red stop sign symbols here are used to start running the program that you've written, or stop it if it's still going and you need to get back to working on it. Right now, we have a block of code that says, when green flag clicked, wait 1 second. This white circle, you can click on and change that number to whatever you want. Just any kind of number to make it wait longer. You can even put in decimals. Wait 0.5 seconds, wait half a second, and then, well, then what? Well, that's up to us. See, in these different colored code bricks are different things you can tell the sprite to do. Let's go with motion at the very top. It's something you're going to use a lot of, and we want it to move in a certain direction. So we're going to take the very top code block there, move 10 steps. You click it and drag it over and put it at the bottom of your block of code. When green flag clicked, wait 0.5 seconds and then move 10 steps. So if we click the green flag, we get to watch him move. Now, how big is a step? Not very big, but you can make the number in the command bigger. Let's try 50 steps. Green flag, there we go. Now if you want it to look smoother, because it kind of just looked like he popped over, down on the list of code blocks, we have glide. So I'm going to take out the move block. I'm going to put in glide. Glide has a time limit for how long it will take the sprite to move, and positioning, X and Y. So if you haven't covered this in school, X and Y are grid coordinates. X goes lengthwise, width, and Y goes up and down. So right now, if you look at our details box underneath the program box, you can see that our sprite, Scratch, is currently located at X minus 60 and Y minus 11. So in our glide box, we can change what position we want him to go to. Let's say X minus 40 and Y 0. That's a different set of coordinates, and it's going to take him 1 second to move to this new set of coordinates. So let's click that green flag. There we go. What if we want him to move faster? Well, it also depends on where he starts. You can click and drag him to a different location to begin with, but glide always brings him to a very specific location. So, the farther away he is, the faster he glides over, because he has to get there within 1 second. You can also change the amount of time that it will take for him to get there, and then press the green flag. There you go. All kinds of options. There's also the turn movement commands that you can use, and the number of degrees will tell you how far he turns. We're going to turn him one way and then back again. Same number of degrees each time. So, start him out down in the corner, and now you'll notice that you didn't see him turn because there's no time in between. The computer calculated it so fast, you didn't even see it. So what if we go back to control and get ourselves a wait command? Now, Scratch likes to try and make things easy to use, so you can actually slide a command in between two other commands you already have, just by hovering over the line between them. And it clicks right in like a Lego brick. So now we get to see him turn and turn back. What if we wanted to turn farther? Just change the number in the degrees. And there you have it. If you want him to turn more smoothly, then you want to have the turn set for a smaller number of degrees, but then have more than one turn happening. And again, you don't see it smooth because we don't have weight spacing out the turns. So if we bring the weight over, and let's make it pretty quick though. Let's say 0.1 second. And if you right click on it, you can select duplicate to make a copy of a command. So if we put them in here, then when we press go on the green flag, you get to see him turning. So the control blocks can be used in a lot of different ways to tell the sprites when they should be doing something. We have when green flag is clicked, but there's other options here too that can do a lot for you in programming with Scratch. Now, we're here today not just to tell a cat to run around the screen a little bit. We want to make a game. So, I'm going to click and drag away this whole block of code. And if I have it sitting here, it's never going to activate. It's never going to do anything because there's no start command. There's nothing up here to tell it when to do it. That block is over here, and we're going to give it new commands. Now, the other thing you can do is if you have a code block or a group of code blocks that you don't need anymore, you can drag it over to the side where you got the blocks in the first place, let go of it, and it will disappear. Now, let's say that we want Scratch the cat to move around when we press buttons to make him move around. That we can do. We start in the control section and we want to grab an if-then code block. If something happens, then do the blocks of code inside of it. that little hexagon shape that kind of looks like an empty spot, you'll see it in a lot of different code blocks, and you can fill that empty spot with green operator blocks that help identify what it is that it's looking for. You can also fill those with some of the blue sensing blocks. Sensing blocks help you make code happen when a certain thing occurs that the program is looking for, is sensing for. For instance, key pressed. Right now it says key space pressed, but that little down arrow means that you can click on it and change what key on the keyboard it's looking for. So I'm going to set this to the right arrow. If the right arrow is pressed, then what? Well, then we want Scratch to move to the right. So we'll go over to the motion blocks, grab move 10 steps, put it inside there, and we now have a code block that says if the right arrow key is pressed, then move 10 steps. And because we put this block of code inside the code window for the Scratch the Kitten sprite, then this code will affect Scratch. It will not affect the butterfly. If we select the butterfly, there's no code there at all. So, with Scratch, now when we press the green flag, it will check to see if the right arrow key is pressed, and if it is, Scratch will move 10 steps, and if it's not, it'll keep going to the next block of code. But right now, when code is written, it only checks through one time. What we need to do is go to Control and grab a forever block. This tells the program that whatever is happening inside of it gets repeated forever. It just keeps repeating and repeating and repeating and repeating. So when we click on the green flag and then press the right arrow, Scratch moves. But what if we want him to go back the other way? Well, then we need to do the same sort of thing again. So let's press the stop button. And back in this block of code, repeated forever, we have if the right arrow key is pressed, then move 10 steps. We can embed more programs inside of there. So if the left arrow is pressed, then move -10 steps to move him back. So when we press go, left arrow makes him go left, right arrow makes him go right. Voila! And then we stop. Now what about up and down? What if we want Scratch to move up and down? Well, we can build more of these blocks for more keys, but an easier way would be to right-click and duplicate. That grabs not just the block that we were right-clicking on, but all the blocks beneath it that snap onto the bottom. Now that we've put that in, we want to change the arrows to up arrow and down arrow. And then moving steps won't really help us with up and down because steps are understood by the Scratch programming software to only be a matter of right or left on the screen. What we can do, however, is grab the change Y by a certain amount. We can take out the move blocks and change Y by 10 or change y by -10. So what we have here is now a single block of code that starts up when we press the green flag. It repeats forever, checking to see if you are pressing any of the direction arrows on the keyboard. And when you press an arrow, it will move the sprite that we have put this code inside. Scratch the kitten. So when we press the green flag to test, he moves right, he moves left, he moves up, he moves down, wherever we want to send him. Woo! Meow. There we go. So we stop and we click Save Now. Always keep saving. Now, we've got Scratch. He's all coded up, ready to go. We can move him around on the screen wherever we want. But what do we want him to do in this game? I think we should have him catch a butterfly. But Daniel, you say, Scratch moves when we press the buttons, but the butterfly doesn't move. That is our next coding step. We select the butterfly, and now we want to give it a set of commands that will make it move without us touching any buttons. So it's going to start in a very similar way. We go to Control and Events, and we bring over the flag. We go to Events and bring over the flag, and that's the start of our code block. Then we want motion. There's lots of ways that we can run this. We can put together our own set calculations for where it's going to glide and give it very specific directions on where to go. Or we can go to random position. The problem with going to a random position is that it just transports over. It doesn't really move. So that doesn't help us too much. But we have another option here, glide to random position. When we do that, it moves. But each time we press it, it moves. It's not continuing to move because we need a control block to repeat it. Boop, 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 boop. Here we go. Now when we press go, it just keeps moving wherever it wants to go. But what about Scratch? He's trying to catch the butterfly. Well, we can move him around wherever we want. But right now, nothing happens when Scratch and the butterfly touch. So, we need to change that. We hit stop. We take a look at our code. We drag the butterfly away, and we're going to add something else into the butterfly's code. So, if we want to have the butterfly and Scratch interact, what we want here is actually not a repeat forever block. We want a repeat until block. If we put the glide randomly into there, we still need to tell this when it should stop repeating. Repeat until what? If we go over to sensing, one of the helpful little blocks here is touching. Repeat until the butterfly, since that's the sprite we are programming inside right now, repeat until it touches Scratch. So it's going to keep repeating, gliding around until Scratch can touch him. So we press green, we can move Scratch around to try and catch him, and there we go. But all it did was stop moving. It didn't do anything else interesting. What else could we make it do? The answer is lots of things. There are lots of options in Scratch so that you can have it play sounds when something occurs. You can make variables that will trigger different effects after other things have already happened. We can make more butterflies. We can make all kinds of things. To be perfectly honest, in Scratch, the possibilities are just about endless. When you go back to that main page with all those projects that other people have made already that you can go and check out, you'll see some of the possibilities out there. What we've covered here today is just an introduction, but it's enough to get you started. And really, the next step from here is for you to poke around and play with the code and make your own creations. I've had a blast working with you, and I really hope you enjoy working with Scratch coding from here on out. There's a lot of potential, and we here at King Township Public Library can't wait to see the things that you guys come up with. Have a good day!